Okay, so today we are going to go over trig functions in right triangles, and we're going to apply those ratios to help solve for some of the unknowns. Okay, so first I'm going to go over the trig ratios with you. It's probably been a while since you've seen these. And you can write these in the box up at the top. We're not going to use the side numbers. I'm going to just use opposite, adjacent, hypotenuse. Okay, and then this angle down here that they give you, that's not a zero, it's a theta. Okay, it's this little oval circle with a squiggly line in the middle, and that's all you have to do to write it. So from this angle, the side across from it is your opposite side. The side that is connected to it is your adjacent side, and the side across from the right angle is your hypotenuse. Okay, so you arrange your sides always in relation to what angle you're looking at. Okay, so you have your three familiar ratios that we're going to talk about, the sine, cosine, and tangent. Yeah, so you guys remember, I'm sure, SOHCAHTOA. For your sine, for angle theta, and my angle symbol, I put a little arc through my angle. You don't have to do that if you don't want to. You can just make a regular angle symbol. Okay, so your sine is going to be the opposite side over the hypotenuse. Your cosine for the angle is the adjacent side over the hypotenuse. And then your tangent for the angle is the opposite over the adjacent side. Okay, so now we're going to go over three new ratios, which are related to each one of these. The first one is the cosecant, which relates to your sine. And cosecant abbreviates to CSC. That should be a small c. So your cosecant for the angle is actually just this ratio flipped over. It's the inverse. So it's hypotenuse over opposite. That's why they're related to each other. Then you have your secant, which is SEC. That's related to the cosine. And that ratio is hypotenuse over adjacent. And the last one is called the cotangent. And that ratio is going to be the inverse of your tangent, which is adjacent over opposite. Okay, any questions? So on example 1, it says find the values of the 6 trig functions for angle K. And the examples that we're going to be doing are very similar to what you're going to do on your assignment. I have a worksheet for you. So for this first example, they're not asking you to solve anything. They just want you to write the ratios down. Okay, and they give you this triangle. KLJ, and the sides are 5, 12, and 13. So if they give you a triangle that does not have all the sides defined, with values, then you will have to solve for the unknown side, but you're not going to actually divide it out. You're just going to write the ratio down. And they want us to find the values for angle K. So I'm using this angle up here. So here's my right angle. Sorry, I didn't add that on there. So I know that the side across from that is going to be the hypotenuse. The side that helps make up the angle K is going to be the adjacent side, and the side across from angle K is the opposite side. So your sine for angle K is the opposite over the hypotenuse. And you're just going to leave your answer like that. if you can reduce it, you do want to reduce it. You always want to simplify. And then the cosine for angle K is the adjacent side over the hypotenuse. And your tangent for angle K is the opposite side over the adjacent. And I want us to do all 6, so I'm going to do cosecant, secant, and cotangent also. But I don't really have to look at my triangle to do those ratios, because all I need to do is look at the corresponding sine, cosine, or tangent and just flip those ratios over. So cosecant is 13 over 12. Secant is 13 over 5. And cotangent is 5 over 12. Okay, any questions? Now we are going to use your calculator some to get some values, but they'll tell us, you know, to round to the nearest tenth or whatever, and I'll know I want to go ahead and find those actual values. So if you don't have your calculator out, go ahead and get that out. Is everybody finished with this side? I'm going to turn it over. I'm going to get rid of this one. Let's look at example 2. We're not quite ready to start using the calculator, but we're ready when it's time. Okay, so on example 2, it says if tan for angle B is 3 over 7, find the exact values of the 5 remaining trig functions for B. So I'm going to draw a picture for this one. They don't give you a picture, so I'm going to draw one. And there's my right angle. So I know that the side across from that right angle is the hypotenuse. And that's really the most important side to know, because A and B, those two sides, are kind of interchangeable. It's just that this ratio is important with the opposite and the adjacent, depending on where I put angle B. And it doesn't matter if I put angle B up here or down here, you get to pick. I'm going to go ahead and put angle B down here. Okay, so since my tangent is 3 over 7, that means that the opposite side is 3 and the adjacent side is 7. So I need to solve for the hypotenuse. How am I going to solve for the hypotenuse? Pythagorean theorem. Okay, we're going to use the a squared plus b squared equals c squared. Doesn't matter which one is a and which one is b, really. Traditionally, the side across from angle B is side B. So I'm going to go ahead and make that side B. So that would make this side A. So we got 49 plus 9 equals c squared. 58 is c squared. So how am I going to find c? Take the square root. And since I'm talking about a length, a measurement, I'm only going to use the positive root, because we don't measure with negative numbers. So square root of 58 is c. Can I simplify the square root of 58? If I divide that by 2, that's 29. 29 is prime, so there's really nothing I can take out of it. It's just going to stay a radical. Okay, so go ahead and write that down there. So I got the sine for angle B, cosine for angle B, and tangent for angle B. And I'm going to go ahead and put the tangent down because I'm going to use that when I want to write down the cotangent. So my sine value is the opposite side over the hypotenuse. And I can't leave a radical in the denominator. So what do I need to do? Multiply top and bottom by radical 58. Right. Got to rationalize it. Okay, so what I'm going to wind up with is 3 radical 58 over 58. And that's going to be your answer for the sine of angle A. Cosine of angle B is the adjacent side over the hypotenuse. Again, I'm going to have to rationalize it. And we're going to wind up with 7 radical 58 over 58 for the cosine. Okay, so now I want to get the cosecant, the secant, and the cotangent. Cosecant is just your sine flipped over. And I'm not going to use the rationalized fraction because then I'd have to rationalize it again, right? I'm going to use the first one because I don't have a radical in the numerator on that first one, so it's all good. It's simplified already. And then your secant is the cosine, the inverse, radical 58 over 7, and cotangent is the inverse of tangent. Okay, any questions? All right, let's look on the next page. On the next page, they give you those special right triangles at the top. We worked with it a little bit last week on your reviews. It didn't really print off very good, so you need to go ahead and make both of the sides at X on the left one, and on the right side you have that X. You need to go ahead and make that an X too. So on this left one, it's a 45-45 right triangle, so it's an isosceles right triangle. Since the angles, the base angles are the same, then that means your opposite sides are equal to each other also. And to get your hypotenuse, you're just going to take the leg times radical 2. And that's how you get the hypotenuse. Then for your 30-60 right triangle, the side across from your smaller angle is the shorter side. Okay, the side across from your bigger angle is the longer side. Of course, the longest side is going to be across from your 90-degree angle. But this shows you the relationship between the 3 parts. The shortest leg is X. To get the longer leg, you just take the short leg times radical 3. And to get the hypotenuse, you just double the short leg. Alright, so let's look at example 3. It says find X using one of the special right triangles. And the one that they're giving us is the 45-45. As if one angle is 45, the other one has to be 45 to get your 180 degrees. So that means that your sides are going to be the same length. And all you need to do to find the hypotenuse is take a leg times the square root of 2. And you're going to leave that in radical form. You don't need to find a decimal unless it says that in the directions. Okay, any questions? Okay, you guys do number 2. Let me redraw that triangle for you though. It kind of came out wrong. This angle's 30, opposite side is 14, and then that side's X. So go ahead and solve for X. I'll do it up here. Okay, any questions? So you're just taking the short leg times radical 3 to get your longer leg per the 30, 60, 90 triangle in the right hand side of your paper. Alright, so let's look at example 4. Use a trig function to find the value of X. Round to the nearest tenth if necessary. So this one I want to actually calculate something out on my calculator. I'm going to find X to the nearest tenth. So the first thing you need to do, look at your calculator, and right next to the second function key there's a mode button. So press the mode button after you turn it on. And about the third one down you have radian or degree. So degree needs to be dark. If radian is dark, just press the arrow over and make your degree dark and then enter. And okay, is everybody good? All right, so I'm going to quit that. Press second and mode, and you get out of that screen. So for example 4, I give you this kind of a right triangle. My drawing's not all that great, but this angle is 24 degrees. This side is X, and the side across from the angle is 11. Okay, so what trig ratio are we going to use with the opposite side and the adjacent side? Tangent. Okay, so I'm going to set the problem up. The tangent for the angle equals the opposite side over the adjacent side. So to solve for x, first I need to get it out of the denominator. So I'm going to multiply both sides by x. And then I'm going to divide by that tangent of 24. Okay, so we're just going to type that in just like it appears. I'm going to put parentheses around the denominator though, and you'll have to close it with a double parenthesis. So you got 11 divided by tangent 24. Enter, and x is about 24.7. So pay attention to what they tell you to round it to on your assignment. They might have you round it differently. So just make sure you're paying attention to that. Any questions?
What did you say then? Because I put exactly that and then got negative 5.
Okay, so you got to go back to your mode and make sure that your degree is dark. If it's not dark, you got to arrow over to it. Okay, and then you should get the right answer. Did you do 11? So I'm playing to get right here so you can see how much. Okay. Let's look on the last page now. Is everybody doing okay? Example 5. Inverse trig ratios. So when they're talking about inverse trig ratios, they're not talking about secant, cosecant, and cotangent. They're talking about when you have the ratio and you want to find the angle. That's what they're talking about. Okay, so far what we've done is we've had the angle and we found the other side. Now we're going to do the opposite of that. So on number 1, it's kind of messed up again. I cannot draw a right triangle like that. So this is your x here. This side is 15 and the hypotenuse is 17. So what trig function would I use for opposite and hypotenuse? Sine, right. Okay, so let's set it up. The sine of angle x is the opposite side over the hypotenuse. So I actually want the angle now, right? So what I've got to do is I've got to use the inverse sine of 15 over 17, and that's going to give me the angle measurement. Okay, so in your calculator, you're going to have to press the second function and then sine, and that gives you the inverse, and then type in your fraction. And the angle is about 61.9 degrees. And go ahead and put your unit on there. Yes?
So whenever you're finding an angle, do you always use the inverse?
Yeah. Okay, so go ahead and do number 2, and I'll do it up here. You got to decide what ratio you're going to be using. Any questions? You should be getting about 56.3 degrees. Okay, let's look at the last problem. Example 6. You're dealing with angle of elevation and angle of depression for this one. Okay, so for angle of elevation and angle of depression, you always have this horizontal line. So if you go up from the horizontal line, that's an angle of elevation. If you're going down from that horizontal line, that is an angle of depression. Okay, so the problem, example 6 says a 14-foot long ladder is placed against a house at an angle of elevation of 72 degrees. How high above the ground is the top of the ladder? So your horizontal is going to be the ground. Okay, and it's going to be perpendicular to the building because the building's vertical. So that's where your right angle is going to come from. Then you have a ladder leaning against it. So we're going to put a ladder out here somewhere, and it's leaning against the building. And they want to know how high it is from the ground. And they're talking about the angle of elevation is 72 degrees. So here is your angle of elevation because it's going up from the ground. Okay, so what else do I know in this problem? Okay, the ladder is 14 feet long. So they're giving me a unit of measure. We need to make sure and include that in our answer. What trig ratio am I going to use for this? Sine? Okay, so your sine 72 degrees equals the opposite over the hypotenuse. So I'm going to take the sine of 72 degrees, and multiply by 14, and that's going to give me the x. So let's see, sine 72 times 14, and I'm getting that x is about 13.3 feet. And I'm just going to put a little foot mark